So, I'm thinking, I don't care where you store it. I want you to understand why I'm putting it here. And the purpose that they wanted it with the transactions was because they wanted to determine, how that transaction was processed. And date of birth was used during that process to give discounts.
Okay.
And what was happening, was people would give a different date of birth, through that business process so they could get the discount, which was quite different from the date of birth that we might have stored on our customer databases. So oftentimes you're going to want to, and I want to know the information about that particular thing, about that transaction. And, the business will actually say, and I've, worked with quite a few people doing, developing data models with the business, and they'll tell you when they want something there, and they'll tell you, when the relationship isn't correct. So I look at data models as a communication tool. It's so that we understand the business information that's needed, as well as the relationships with that data, because it is all about the relationships and the definitions. So I'd like to ask a question to everyone. What are the skills that you believe make a good data modeler? And if you guys can just, put it in the chat, and we'll take a look at what are some of the things that you believe is an important skill for a good data modeler.
They're all busy analyzing that model at the moment.
Yeah, don't analyze that model. I'll have to tell you what that model is while you're thinking about the good skills. That was something that I did for DAMA Australia. That's why I'm sharing this one, because I used to be on the board for the DAMA Australia chapter. I was the treasurer, and we were, creating a little mini database thing here for the information that I wanted to know about what was happening with DAMA Australia. So it does have, it's probably too little for you guys to really read it, but it has, membership and events and attendance and all kinds of lovely things that I wanted to know about what was going on with all of our events and with our membership. So
we've got some answers coming. So
what are they?
Well, the top one, of course, is being female.
Yay!
Outside box thinking, business understanding and communication.
Yay, we got a communication.
Understanding the business language, good understanding of business and requirements, understanding the business rules. We've got understanding and communication. And of course, so there's a couple of things that understanding requires.
Okay, is that our?
That's it.
That's it. Having an understanding of the business, I think, is extremely important. I had someone one time who told me that I didn't need to understand the business. I just needed to be able to draw, entities and relationships in a data modeling tool, which I found that absolutely astounding. But I think one of the reasons, since this is a women's, data modeling kind of thing, I think one of the most important things about important skills for a modeler, data modeler, to have is listening. Not jumping to conclusions, and not thinking about how I'm going to design the database, but rather actually really listening to what the business are saying, being practical, and having really good negotiation skills, in that getting people aligned, because doing a data model is an awful lot about the language of the business. And we all know businesses work in silos. And we all know they create their own little languages, and they're often misaligned, both in terminology and in the definitions. And being able to get those people together to be able to talk about those things in a non-threatening environment, and to be able to get them to actually listen to each other, is really, really important. But a lot of those were very, very good answers. I just want you to add listening to that skill set.
There's a question here. How did you resolve the differences and not abstract?
So that was from me. So I mean, we all know that business have very different understandings or different messages, and how do you fix those? How do you reconcile the different views?
Let's see if I can give a good example. One of the things that I will do is whenever I've got a term that we're defining, I will go into a discussion in a workshop with my business with, I'll be armed with all the different definitions that I've already got. If I don't have any, I'll go out and research ones. I will actually use the dictionary and I will challenge the actual terminology that people are using, because it is about language, and if I were to define something like, I'll give you an insurance company one, because I have so much background in insurance. So premium, you would think everyone knows what premium is. We pay premiums for our insurance. The insurance company charges a premium for that insurance. I worked at an insurance company that had, what was it? 96 definitions for premium. Same insurance company. What they were really doing was defining different things, whether or not it was paid premium, earned premium, unearned premium, written premium. They called it all premium, but when you dig down into what exactly it is they're talking about, you end up finding out that you need to qualify these things. So you don't really change the language. You're really just adding a qualifying word to a lot of terms.
Adding more types.
More types.
Yeah.
All right.
When it is just one term and that's not a type, and they're going to argue about it, which they will, then I start with, where does this thing originate and who's going to take accountability for it? So then I start to bring governance into the discussion, and whoever's willing to put their hand up and be responsible and take accountability gets to name it.
Okay.
You'll see a lot of people back down after you say that.
That's for sure.
But it often actually ends up belonging, or originating from a certain functional area. One of the probably, what's the word I'm looking for? I'm losing my words now. One of the problems, I'll use problem, it's not the one I want, but one of the problems with data models and such is that it is two-dimensional.
Yeah.
And there's a lot of relationships in there that cannot necessarily be represented in a two-dimensional model.
Certain level of compromise.
Yeah, the compromise was the word. So you are going to have compromise when you do a data model. But you'll find out that the data itself will originate from a given functional area. And if you can take it, to that functional area, because it starts somewhere, it might be passed to other areas and shared across the organization. Like the lovely thing called customer. People will say everyone owns the customer. Well, do they really? Because if you think about it, in a lot of organizations, you're going to have an area that's going to handle your consumer type customers, or your large business and enterprise type customers, or, so you'll find that area that actually owns and knows the most about that, in which case, and it's where that data and that information actually originates. They should be the owner and then actually have the authority to say, this is what it means. This is the name, and get everyone else to follow suit. I'm a bit of a dictator, I guess, sometimes. Yeah. Okay, this will be a quick one. Because I have a preference for IE notation and my, third normal form models, I just wanted to mention that this notation that I use was created by Clive Finkelstein. He was an Australian from Sydney.
No, that's not.
Oh, no. The wiki and his wife says he was born in Sydney.
Oh,
he might have lived in Perth,
okay.
but he was born in Sydney. I went and looked him up.
All right, thank you. I stand corrected.
But he is an Australian. And, you know, well, he was an Australian. I do say that because he did pass away recently in September 2021. But the reason I'm bringing this up is one of the things that Finkelstein had commented on, that he used to get a little upset that everyone misinterpreted what his notation meant. That the lovely little thing, you know, over here, if I can do this, where's my thing? That did not mean one, it meant mandatory. And the zero little circle here does not mean zero, it means optional.
I didn't know that.
People always read those as that's 0 or 1 or whatever. And he says, no, straight line means mandatory. Circle means optional. And when I have something like this, you know, a little circle with a mandatory, it means optional becoming mandatory. So I will eventually have one or more. I may start out with no relationship or a null, but I will eventually have one or more.
What happens if they never? What happens if a record never becomes mandatory?
Then you're up here at, well, you would just have a 0. You wouldn't have a relationship. You mean if it
would be optional only.
It would be optional only.
Yeah, not the optional becoming mandatory. It would just be optional.
But I don't see that on your notation.
Oh, we haven't got all of them on there.
Yeah, there's actually 16.
Oh,
yeah, I think there's 16. There's 8. These are the most common ones. There's 8 that are for the mandatory, you know, notations going in both directions.
Okay.
And then there's 8 more that are the optional going in both directions.
Right. Thank you.
Okie dokie. So I just thought I'd share this one. I've also in my career have heard many arguments as to what is the best architecture for a data warehouse. I know this is about data modeling, you know, but the same academic arguments that happen in data models also happen in architectures. And in my opinion, you know, that has nothing, the architecture of data warehouse has nothing to do with developing your business or conceptual data model. So the choice of architecture should always be aligned to your data warehouse strategy. Now you've got time and quality. If you want quality and you've got lots of time, you could do a, you know, normalized model. If you want it quick, you want a data mart that supports a specific, you know, dashboard, you could do dimensional. But I've also heard arguments that dimensional models are easier for business to understand. That is not my experience. My experience has always been, you know, that the business people that I have worked with for many, many years have always been able to understand very easily a third normal form entity relationship diagram. And I really hate it when people say, oh, business won't understand a data model. They don't have the patience. You know, I think in that case, it's a data modeler who doesn't have the patience.
Is that also because you haven't, is it that intense normalization or removing the many-to-many relationships? Is it sort of impacted how pure that model becomes? Or is it, you know, if we go to fifth normal form, would it still be readable? Is that your experience as well?
I have never gone to fifth normal form. The very most I will do is a third normal form model. I will resolve all many-to-many relationships. And I don't resolve them with an entity in the middle, an associative entity.
Right.
To me, resolving a many-to-many relationship means you don't really understand the business well enough, and you need to go and figure out, because typically that many-to-many is a process that's happening.
Yeah,
you need to get much more involved and understand. and that will actually give you the real relationships.
Okay.
So if I see many-to-many in a data model, then I cringe.
Okay.
There's two people that I know, Daniel Moody and Mark Kortink, who wrote a really, really good paper on how to take a third normal form and create a dimensional model. So if you need a dimensional model from a third normal form, it is easy to do. So you can use your third normal form, to me, is still needed, even if your data warehouse architecture is going to be a Kimball or a Vault or whatever it might be. For me, a business model would always be a third normal form.
Somebody had their hand up, but it's disappeared, so I didn't catch who it was. Was there a question?
Yes, it's me. I do have a question, Terry, on this database architectures. With the new technologies coming in, people are moving towards like the columnar databases, which doesn't need any normalization, and also a dimensional modeling is not needed because data vault architecture, hub and spoke is coming better than dimensional. What is your take on that?
I'm not sure I caught all of that question.
The question is with a lot of the newer architectures coming in, where there's a lot of talk about not needing to do data modeling, and I think that's really down at the physical level, not at the. Anyway, I'll let you pick up from there.
I would say that not doing, if you are talking about physical in the physical world, I would say if you don't want to do a physical model, that's okay. But I would say that you definitely need to have your business model. You do need to understand the data and the information that the business need and the relationships of that information. I don't get into, I try to avoid the battles of architecture. Because in my mind, and especially in the data warehousing environment, to me, your physical platform and all of those kinds of things, you can make those decisions, but it doesn't, to me, does not impact the need to have a good business model and a good language base for your business to work with.
Yeah, you need a point of reference, really, for any data that you're going to deal with. But I think the other thing to think about here is, one size does not fit all. Depending on the data, depending on the business need, you might choose to do a data model, you might choose to just use a flat file, you might choose to do a dimensional model, you might choose to use a vault architecture, but I think it depends very much on the type of data and the particular scenario, because if you think about it, all of the different architectures are solving different strategies. And one strategy does not necessarily fit all types of data.
That's right, but on the 3NF, right, the third normal form, which is actually needed to address some of the relationships and also how it is storing in the database, right? So that is where I'm right now, the columnar database, which addresses no need to do your third normal form. You can still be in second normal form and then still achieve that performance, which is needed, which can be achieved in 3NF.
Yeah, and that's a choice at your technology level, at your physical level, as opposed to your logical or your business model, which is really describing the needs in a form that is digestible by the business community. It can be used as a means of communicating to the database designer how to implement that in whatever type of database technology you're using, whether it's a columnar or in memory or whatever technology you're choosing.
So I think my
logical database has to be done in this level. Physical can be at any way you want. That's what you're saying?
Essentially, I mean, I wouldn't say any way that you want, but I would say in a design that is suited to both the data needs in terms of access to the data, storage of the data, maintenance of the data,
Your business objective.
and your business objective. So you need to satisfy a lot more than just the technology consideration. And this is where I think a lot of technology is chosen before, too early on in the process. Quite often we jump at technology because, well, let's face it, a lot of the senior executives are getting kickbacks from IBM or whatever, or that's their love of a particular technology. But I can't quite see your name there.
My name is Sudhakar. My name is Sudhakar. One last question. Sorry, I'm taking more time, but
on architecture.
No, this is great. This is great.
One last question is like, yeah, I understand the business relationships and the need for the logical this thing, but with the technology evolving, even business processes and some of these things are changing quite fast, and there's no need for these kind of detailed logical structures and data virtualization, columnar database, which is redefining you how you're going to define. Of course, when you're talking about the business, the reporting requirements or those kind of things, yes, absolutely, the logic needs to be defined and where it needs to be there. But in terms of detailed entity ER diagrams and dimensional modeling, extended star schemas, those are all not quite latest things which I experience, which is not needed.
And you know there are changing needs. Absolutely, there are needs that are changing. And I think Sudhakar, I think you mentioned TMF. Did you mention TMF, Telemanagement Forum?
No.
Okay.
I didn't hear
That's
that
okay.
one.
I was going to prompt Terry to talk about industry models, but we'll move off of that. Sorry, Terry,
yeah,
you carry on.
The only point, the only reason I brought up architectures, data warehouse architectures, is that I have heard in my experience many arguments, about the best architecture for a data warehouse, and in reality, the business don't care what IT chooses as an architecture as long as it is aligned, to the data warehouse strategy and what the data warehouse is trying to deliver. What are the business needs? So for me, my role has always been developing and working with the business to identify those business needs. What information do they need? How does that information relate to each other? I have used data modeling as the communication tool to work with the business in developing those. And
that makes sense, Terry. Thanks for the clarification.
Yeah, I have, and my experience has shown that that the business quite easily understand a data model. And they'll often tell you when you've got it wrong. When those relationships are wrong. I've spent years running workshops with them, and I have built many data models with business people in the workshop. I don't just ask them questions about what they need, and what it means, and then walk away and put together a diagram. I actually draw the diagram on the board with them in the room. In which case they get to participate in it. They get to learn. They get to share knowledge between the different units. And best of all, they actually understand and know what they're going to be getting from their warehouse.
Need to move on. It's 10 to 1.
10 to 1. Yeah. Okay. Well, I won't go through the history lesson then, because that's really all about, where I started diagramming sentences as a kid. And most of you probably don't even or have never heard of diagramming sentences. But I just found it really interesting that I used to love to do that. And it taught me quite a bit about the structure of language. And that language does have a syntax. and a structure, and that structure is called grammar. And I think the experience of doing sentence diagramming very much led me into data modeling, because understanding the syntax of language and sentence structures helps you to understand, well, the language of the business. They often say that a picture is worth 1,000 words, but it often takes 1,000 words to explain the picture, especially if it's too technical. So I find that the problems with some of the data models is that it requires compromise, that I mentioned before. It's a two-dimensional depiction, so it doesn't really give you all the different relationships. The definitions have to be very good for people to understand them. How many models have you seen that have no definitions associated with it? So today, I actually use natural language when I'm working with the business. And I start with definitions, and I start with a very structured way to write a definition, which kind of uses both my experience in sentence diagramming and data modeling. But I start with that business term, and I'm able to structure a definition and identify all the different relationships, starting out with what is the business thing term I'm trying to define? What does it do? What's its purpose? So we start with, all the given business rules, and even identifying, using that structured methodology, what those option phrases are, whether it's mandatory or optional, using what we call modal verbs: will, shall, must, can, may. And when you're done with that structured definition, you get to see the relationship of the term to other terms. And each rule is structured, so a related term, is at the end of that given rule or clause.
This solves some of the problem of the speed of data modeling as well.
Yes, it does. It helps. I mean, if you write your definitions in a very structured way, it actually aids in creating a data model. It does make it more rapid. It makes it more compatible with agile methods, because they always seem to think that modeling is a bottleneck. And in this case, if you're doing a very structured definition and getting business to actually, read each of these and approve each of the business rules, each part of the definition goes much quicker. I worked in an insurance company here in Australia where we handed over structured definitions, and the data modeler was able to much easier and quicker create a logical data model for their warehouse. So I guess that'll probably wrap it up. If anyone is interested in learning about how to write those structured definitions, we're doing a free web class on writing clear business definitions. So you can find more about that from this QR code. So I think what we can do is open it up to more questions.
Fantastic. Thanks, Terry. If you wouldn't mind providing those details for us for the free web class, we'll certainly advertise it as part of the post. Mark, that would be really helpful. Then we'll just present
Sure.
more.
And I think you had a slide with some further reading as well.
I do. I don't know what. From resources, I think some of the best data modeling books that I have seen is one that's called Data Modeling Essentials, written by Graham Simpson and Graham Witt. Graham actually followed that up with another book called Modeling for Data Quality. And they're much more business focused type of models. And this is also the paper, in case anyone is interested, that was written by Daniel Moody and Mark Kortink on how to take an enterprise third normal form model and convert it into a dimensional model.
I've actually found that method, their analysis method, really good for analyzing source data. So when source data is generally very normalized and you get the structures, you can very quickly analyze that to create dimensional models to quickly analyze the data. But quite a powerful method.
Okay. And Mark, have you had any experience with the unified star schema from Pupini, the Francesco Pupini?
No, I haven't, to be honest.
So he also tries to, he tries to suggest in a way a technique for converting your relational models into a standardized dimensional model that one can keep on adding to and uses the bridge approach.
Interesting. Yeah, I'll have to look up on that one.
Yeah, I'll put the reference in the chat.
Yeah, that'd be good.
Thank you. Any questions? And maybe just to add a comment to the previous discussion, I certainly understand that that the dimensional model came out from battling with the inefficiencies of multiple joins, and so it was almost a lot of the times it was derived or reason for creating those scenarios. And now I'm sure we're seeing with lots more processing power, some of those reasons disappearing. So we created these physical dimensional models for efficiency's sake. But yeah.
One thing I just want to share again, there maybe some discrepancies on the business models and what actually is. I'm part of one implementation right now. We're going away from dimensional modeling to a big table kind of this thing. The Google's BigQuery and the columnar database. We could able to achieve more than 30–40% performance from dimensional modeling to coming up with a big table, the columnar database. So performance improves are a lot. And again, I'm not talking about everything, put everything in it. There is a business logical structure will be there, logical joins will be there, but we could able to reduce all that dimensional modeling and create a simple big queries, big tables, and then simple joins, which improve performance a lot on Azure platform we implemented. Just
I think you're talking now about almost a wide data set that data scientists use to flatten everything out. So that's more of a physical technique to achieve a lot of that. And going to document databases like JSON to reduce the I/O. But these are physical issues. I think as you say, the business logical and the fundamental data elements are still there to be understood and modeled. I don't think we can ever get away from that. However, it's in translate.
Again, Terry and someone, I think probably they can talk more. So business, I completely understand business entities and relationships we need to define and everything. So previously when it was Inman and Kimball world, it used to be a one-on-one with business entities to your normal forms. Again, correct me if I'm wrong. That's where it is getting changed on the physical level. The technology is so much advancing. The business entities probably will change, but will stay. But the physical entities will completely change, which is going to probably create some problems with the business logic as well. I think again.
My understanding of what Inman suggested when he created that warehouse third normal form was to ensure that the integrity and the quality of the data existed across multiple applications. So it was about uniting the data in a structure that came from the business rules, the business logic and definitions. And then when you brought all this data from multiple systems into one area, it would enforce some of those rules. And that's why we then brought Data Vault in there, because some of the data was getting left behind in the applications because the quality was too tight. But it was achieving a different scenario in that it was unifying the data across multiple applications. That's certainly my understanding of why that enterprise data warehouse came about.
Yeah, that's my understanding.
That's my understanding as well.
Sudhakar, does that give you a bit more answer to your question?
Yeah, I agree on business understanding and the integration of the multiple systems and all. What I'm trying to make sense of it is like understanding this dimensional ER models in a current world, current technological world where it can optimize. I'm not talking about the business processes at all. I mean, that stays the same. Business modeling side of it, it stays no matter what technology is. But the physical side of it, how we are going to store and how we are going to access, which is actually previously the Inman and Kimball specifically, there are tools implemented with that thought processing is going obsolete, is my point.
Yeah, I think they're different. I think they're different issues here. For example, both Kimball and Data Vault and Inmon, they created those downstream data marts for specific reasons, for specific quality requirements. So even when you look at Data Vault, when they come in, it can stay there until the data reaches the appropriate level of quality for reporting, and then it goes to a downstream data mart. So there's more to it than just a practical and a physical efficiency, because you're right. I mean, if the only reason was physical efficiency, then as the processing gets faster and bigger, then almost to an extent, it doesn't matter what you have. I mean, I still have challenges where we're still seeing that you can't load the entire warehouse into a in-memory database because it still has challenges. So we still haven't overcome that from a cost point of view. But you're right in saying that from a physical point of view, all of these gymnastics that we were performing are no longer necessary. I think we're all in agreement with that. But there are reasons for slowing things down and only getting to the data mart and only reporting when it's clean. That's still happening, whether you go Data Vault, whether you go any of these things. You still, for example, in compliance reporting, you do not want to make a mistake, and you don't want to have dirty data. So those things are still there.
Yeah, that's a very good example, Howard, in terms of, as I said, each business case has different requirements. So if you're doing something like a fraud detection system, this is a marketing system, you're going to be looking at two very different architectures to handle because you have to look at the quality as well. The Kimball star scheme, the snowflakes and so on, most of those designs are done from first principles. So there's no real rigid data modeling design approach implemented. Those they are done by quite often done by the developers. And what I have seen in some very large data warehouses where that has been allowed to occur time and time again is the spaghetti mess that ends up because data is taken from the nearest available spot to create some new data, becomes unmanageable and untrustworthy.
Yeah.
And then you lose your audience to the data, or you are making decisions on bad quality data or misrepresented data.
And I do like
very carefully. We can run really fast at doing these things, but I think as Howard says, there's still a need to at least understand what the data should be. Versus what we do with it. And of course, remember, your data is historical. Your business is current. So your data will never ever be aligned with your current business thinking. There'll always be some lag, and that could be years, it could be months, it could be dealing with an ERP system that was implemented 3 years ago based on business rules of 3 years ago. Your data is not going to look quite right necessarily.
Right. I mean, I do like the insight that I get when I'm forced for a dimensional model, forced to ask the business, what questions would you like to be answered, and what decisions and what results. So I like that process instead of just throwing everything together and then hoping that you understand what sort of insights they want. There's a lot of value of doing that and seeing what it is that they're trying to answer.
Definitely. Definitely. These are some really good questions, by the way.
Yeah.
Are there any more?
Anybody else? Marley, I haven't seen you for a while. Good to see you again. Any questions from your side?
No, none from my side, but very interesting discussion. I couldn't agree more with Terry that, you know, people say like, shouldn't data model and always too busy for data model, but very much the business data model, conceptual data model is so critical, and regardless of the physical technology you want to use, your physical layer.
I like
So
that.
thanks for that.
Thank you. It was good. Thank you.
Yeah, one more point. Again, I would like to hear your point of view. Is like again, I'm not disagreeing the things you're talking about. The business conceptual model is very important, no matter what the physical side of it. I completely agree with you. There's one more technology advancement which is speeding up the process and which is also addressing some of the issues of the data movement is data virtualization. Some of the technologies right now, because we are moving the data from one place to another, and then there are a lot of issues, and then a lot of time lag between your addressing your business needs. Data virtualization is one technology which is actually you create your logical conceptual model, and then no matter where the data is, you'll be able to connect without moving the data. So that is also one of the things I just want to share.
Thanks for sharing.
Do you have any thoughts on that?
Yeah, I've had quite a few experiences there, and one is everybody jumped on this data virtualization. They thought it was the answer to all sorts of issues. What we found out is that it was fantastic for prototyping. It didn't stand up to lots of the production issues in terms of loading all of the data. So we had some really good success stories initially in getting the prototype, in understanding the data, and in a way building the data model because we could see what data was there. A lot of them didn't go into production due to the size of the data that happened. But what I always found interesting was that it was independent of the JSON documents or the data lake or whatever it was. It was always interesting that we always came back to rectangular data that could be summarized and summations and all those type of things. So it was irrespective of the physical layout, we came back to the logical model and the rectangular model so that people could aggregate and perform mathematical summations on the data. And so it was almost this repeat of, yes, we went into all sorts of forms underneath the covers, but we had to come back again into rectangular data so that we could measure how the business was doing. And so it was almost a repeat of what was happening. But you're right, it enabled the transformation and enabled the ability to come back into that rectangular structure that third normal form of dimensional modeling gave us. Whichever one you chose, it came to that level.
Thank you. Great discussion. Thank you. Thank you for your.
Thank you.
Thank you.
Excellent. Guys, thank you so much. Thank you. I really appreciate it, Terry. I really liked your redefining of those cardinality and different optional areas. It caught me by surprise. Thank you for teaching me. Thank you. I appreciate that.
He was Clive Finkel's. I was lucky enough to see one of his lectures. It was a very interesting lecturer when he was talking about his. Yeah, he was. I think he had his nose out of joint because I can't remember who it was who also claimed that they invented the IE notation.
Somebody Martin.
James Martin.
James Martin.
James Martin, yeah.
Yeah, so there was a bit of a
Yeah.
lost love between those two.
James Martin and Clive and Bill Inman and Ralph Kimball.
And the many-to-manys.
And the many-to-many, yeah.
Yeah, that was a good one.
I like
Your
that.
many-to-many.
I really like
Cringe.
that because it's so much. What I love about normalization, even going to fifth, that you don't implement is what business rules you discover, and each many-to-many is showing you a problem, and showing you that you don't fully understand. And
Yep.
even though you never implement like that, you just the learning and your understanding and your listening to business and asking the questions is phenomenal. What you understand.
Yep.
I really love Steve Heberman's. He said he just joined. They were doing a 12-year data warehouse project. He joined on the 10th year and they closed it down on the 12th year. But whenever he asked his supervisor at the end of his first year or second year for a review, and the guy said, one of your biggest problems, Steve, is you don't feel the data. You're modeling mechanically, but you just don't get a proper understanding of the data and where things are wrong. And that's a really valuable insight that he gave me in terms of looking and trying to understand and feel that data. But thank you everyone.
Yeah, thank you.
Thank
Thanks
you.
for having us. And we wish you well for August.
Thank you.
Happy Women's Month.
And yes.
Yeah.
And
Celebrating Women's Month.
yeah, go girls.
All righty.
That's right.
Thanks everybody. Thank you,
We
Terry.
need
Thank you
more
so much.
females in this industry.
There's not enough.
That's for sure.
Thank you.
All right.
Thanks everybody.
Cheers.
Cheers. Bye.
Bye.